Hello and welcome to Week 8's recording as part of the Foundation degree in Engineering from the Southwest College. My name is Freq, and if you have any questions or queries in relation to this e-lecture, please feel free to email fergal.tuffy@swc.ac.uk, or for the full-time group, please feel free to email glenn.campbell@swc.ac.uk. First of all, we're going to do a quick recap from last week. Last week we covered binomial expansion. So, what is binomial expansion's purpose? Well, binomial expansion is used to expand brackets that are to large powers. And can you remember what is the name of the triangle that is used for the coefficient of expansion? Yes, it's Pascal's triangle. So, what's the general form of the equation a plus b n? So, if you remember from last week, when we looked at the example a plus b cubed, what you saw was that starting at the left hand side, a was to the full power 3, and then was gradually taking one away from each of the powers until the right hand side where a wasn't used at all. So we have a cubed on the far left hand side, then we have a squared, then we have a, and then on the right hand side there's no a component at all, it's a b cubed. So likewise, b reduces, but it reduces from right to left. So at the end you have b cubed, then moving over one step to the left you have b squared, a further step to the left you have b, and then at the start there's no b component at all. And remember then that to get the values, the coefficients that are in front of the a and b terms, you use Pascal's triangle that's at the top right hand side. So you can see on the fourth row down you have 1, 3, 3, 1, and those are the values of the coefficients that are in front of the a and b terms there. So if you were asked a question such as expand p plus q to the power of 4 and hence 2 plus x to the power of 4, what would you do? So first of all, what you would do to revise is you would get the general form of the equation in terms of p and q using Pascal's triangle. That would give you p to the power of 4 plus 4 p cubed q plus 6 p squared q squared plus 4 p q cubed plus q to the power of 4. Once again, if you're wondering where we got those coefficients from, if you look at Pascal's triangle, and the fifth row down you have 1, 4, 6, 4 and 1. So if you're unsure in terms of building up Pascal's triangle and how you get each one of the levels, if you refer to last week's notes where we went through how those coefficients are calculated. So then, if we wanted to hence solve for 2 plus x to the power of 4, we then insert 2x plus 4 into the general form of the equation that we calculated there for p and q. So everywhere that we have a p, we replace it with a 2, and everywhere that we have a q, we replace it with an x. So doing that, this would give us 16 plus 32x plus 24x squared plus 8x cubed plus x to the power of 4. If you're unsure about this, please go through last week's lecture and revise. Moving on. Last week we also covered frequency distribution. So what is the purpose of frequency distribution? Frequency distribution is used to display data in visual form. So you remember, if you're sitting with managers at work, rather than showing lists of numbers, it's often more beneficial to show it in visual form. It's easier to look at, and it's easier to pick the data from more quickly. So what if we have different class widths? What do we do? If that's the case, we need to calculate the frequency density. So for the table above, we have the length, which is the class width, and we have the frequency, for example, the number or the amount of for each of the class widths. But can you remember what is the formula for frequency density? So frequency density is equal to frequency divided by class width. So as in the table at the top, you can now see the frequency density for each one of the components, and this is based upon the class width or the length of each. So, can you remember what is another term for the average? Yes, it's the mean. And how do we go about calculating the mean? Does anybody remember the formula? There are two methods that we can use. One where we have equal class width, and another where we have different class widths, as we have in the table above. First of all, with equal class widths, the mean x bar is equal to the sum of the frequency divided by the number of classes. And secondly, with different class widths, the mean is equal to the sum of the midpoint times the frequency divided by the sum of the frequency. So, in today's e-lecture, we're going to continue on with frequency distributions, data analysis and display topic. And the intended learning outcomes are as follows. At the end of this lesson, students will be able to find the standard deviation to an engineering problem. Secondly, present information in a variety of graphical forms such as bar and pie charts using IT. And thirdly, solve equations and display results for simultaneous equations, also using IT. So well done. Now you have completed the introduction. The next step is to go to the ILO1 video and play it, going through the different activities contained within it. Now please remember that these videos can be paused at any stage for you to go and undertake the activities, and then press play again to resume the video. Now go to ILO1 video. Thank you.